This video is on simultaneous equations, the algebraic method, and it's part 1, which is the method of elimination. So far all we've looked at is the graphical method, and so we're moving on to now to how to solve simultaneous equations algebraically, which is faster than the graphical method because you don't have to sketch both of the functions, or in this case straight lines representing each of the equations. So let's have a look at this first method. So what does the method elimination involve? Well, it requires you to add or subtract the equations. So that's one thing you will have to always do when you use elimination, add or subtract your equations. And the point is this will help you to eliminate one of the variables, and that's why it's called the method of elimination. So can I always add and subtract equations? Well, no, you can't just add and subtract equations unless the variable in both equations has the same coefficient. And I've just said here, ignore the sign. So for example, here we've got 2 and 2, ignore the sign, and we can add or subtract them. And here we've got 3a and 3a, they're identical, so we can add and subtract them. So why can I add and subtract them? Well, what we're trying to do, like I said before, is eliminate one of the variables. So if you look at these equations here, if I have a minus 2y and a 2y, I use this little saying, which I've got over here, which is if the terms are the same, subtract. So same, subtract, different, add. Okay. So if you look at these two terms, we've got minus 2y and 2y. Well, they class as different because they have different signs. But if they're different, we can add them. And if you add minus 2y and 2y, you will see that you get 0. And so by adding these equations, we will eliminate the y's. So that's the point, is that whatever you do, whether it be adding or subtracting, it should eliminate one of the variables. So here, my terms are the same. So if they're the same, we will subtract. So if I do 3a minus 3a, the a's will be eliminated, and then I can solve for y. So in this case, we subtract. Here, the terms are different. You can see the minus with there and the plus. So we're going to add. And here, my terms are the same. So we will subtract. If they're the same, subtract. So let's have a look at how we can do this. We've got here 3y and minus 3y, and I can see that the terms are different because they have the opposite sign. So what I will do is I will add my two equations together. So we're going to do 1 plus 2. So when I add these two equations together, just on the side here, I want you to notice that if I took 3y and add minus 3y, well, that does give me 0. So I don't really want to write that out because it just adds more working to my lines of working. But I just want you to understand that by adding, we will in fact eliminate the 3y and the minus 3y. So we'll have no y terms left, and then I can solve for x. So adding the two terms together, well, adding the x's gives me 2x, and adding the y's, this is where you've got to be careful with your arithmetic. 26 plus minus 22 is 4. If you need a calculator, you can do that. And some people like to write out what they're adding. And if you need to do that, by all means, take those extra lines and set it out like that. There's nothing wrong with that. So from here, we can divide by 2. That gives me x equals 2. And at this point, I'm halfway through the question. What I want to do now is solve for y. So when you want to solve for y, you need to substitute your x solution back into either of the equations. Don't forget that we're finding the simultaneous solution of both the equations. That means that whatever my solution is, it should satisfy either this equation or this equation. It will satisfy both of the equations. So it doesn't matter which equation you substitute back into. I would just use whichever one is simplest in terms of the arithmetic you need to do. And I would say that's probably equation 1, as it has no minus signs. So I'm going to sub x equals 2 into equation 1. And so what I'm going to get is 2 plus 3 lots of y equals 26. Then I can minus 2y, and I get 3y equals 24. And I can divide by 3, and I get y equals 8. And that is my final solution. I found that x equals 2, and I found that y equals 8. All right, let's have a look at another example. Here, my terms are identical. So what I can do is they're the same. So like we said before, if they're the same, we subtract. So I'm going to do Now, whether you do 1 minus 2 or 2 minus 1, it doesn't matter. But what I like to pay attention to is whichever number is bigger I usually start with. It just means I'll avoid a negative. It's not wrong if you don't do it like that, but I just try to avoid minus signs, I guess, avoid simple errors, I guess, making simple errors. So I'm going to start with equation 2 and minus equation 1, but doing equation 1 minus 2 is also perfectly fine. So when I do that, 5a minus 5a will be eliminated, and 4b minus 2b is 2b. So I'm going to do 4b, and I'm going to subtract the 2b. And then I'm going to do 49 minus 27, which is 22. Now, once again, if you're someone who needs to write 4b minus 2b equals 49 minus 27, there is nothing wrong with doing that extra line. I encourage you to do it to get it right. And from there, we can divide by 2, and we get b equals 11. Now at this point, like we did in the last example, you've got to substitute your solution back into an equation. I think both of these look similar in terms of arithmetic. I'll probably go back into one, slightly more smaller numbers. So I'll sub b equals 11 into equation 1, and that's going to give me 5a plus 2 lots of b equals 27. That gives me 5a plus 22 equals 27. I can minus 22 on both sides, and I get 5a equals 5. And dividing by 5 gives me a equals 1. So there's my simultaneous solution, which is b equals 11 and a equals 1. Now I've given you, I think that 2 now here to do on your own. Of course, I've just said you do. And then on my next slide are the answers. So what I would do now is pause the video, take a piece of paper and work out both these questions, and then you can compare your answers to mine. Can I please just also reinforce the fact that you really do need to be showing your thinking. And what do I mean by that? Well, your setting out is important. You need to number your equations. You need to tell me what process is being done. So are you adding, are you subtracting? And once you get your first value, or in this case we found that b was 11, you need to tell me what I'm doing with that solution to get the other pronumeral, the value of the other pronumeral. So please be clear and follow the setting out as I've shown in this video. All right, pause the video, get these questions done, and I'm about to unpause the video to let you see the solutions. All right, here are the solutions. Mark your work, and I hope this has helped you to understand simultaneous equations, the method of elimination.